Jeremy Littlejohn. I'm the CEO at RISC Networks. Certainly we feel gathering application dependencies are important no matter what you're doing, right? But they definitely take on a new level of importance as you get ready to move something, migrate, whether that's to cloud or migrate your data center, or in some cases even consolidate, within an existing data center. So it's really important to understand those dependencies so that you know the impact that moving a single workload or application or process would have on other applications, processes, or workloads. And ultimately that's going to show up in an end user experience or in an application experience that's subpar if you're not aware of what those are. So again, I think it's important for the migration. I think it's important no matter what you're doing. There have been different versions of dependency mapping for several years, such as CMDBs and those types of things. And some of those are really good. What we've really focused on at our organization is giving some additional color to those dependencies. So for example, I know that server A may talk to server B, but the question is how much, how often, what does it look like? What if I separate them, what do I need to support them? Because it's not always as cut and dry as this workload or process is dependent on this workload or process. And so I'm going to move them together. In a perfect world, that's what we would do, but the reality is, for example, in a Windows application, you're going to have a lot of inter-process communication that's happening at the OS level that may be critical to that application, but you can't do a domain everywhere you go. And so what you're going to have to do at some point is make a choice about what I can support remotely or as separated and what I have to keep together. And really the color that we provide is what you need to make that decision. The biggest potential impact is just failure of the application. If you're not sure what that application depends on when you move it, and then there's either a policy issue like a firewall in between that you haven't opened for that, or a VPN that doesn't have the correct crypto maps on it, or you're dealing with, could be a performance issue. It could just be degraded to the point that it's not usable. I mean, that's the worst case scenario, but that happens quite a bit. And so the business impact or productivity impact of that is huge. And if you've moved a data center or you've moved a set of applications to another data center or specifically moved to the cloud, these are moves that are not easy to roll out of, especially in an application that's heavily used because the data itself has been updated. So you can't just say, well, go back to where we were yesterday, we lose all of the stuff today. So what you really need to do is concentrate on making sure that you're comfortable with the dependencies that have been discovered, right? If you're relying on databases that are 2 years old for your dependencies, you may run into trouble. You need something that's current, something that's constantly updated based on your environment so that you can make an educated decision about what needs to move with what. So one of the major differences for our dependency visualization that we did and for our move groups and modeling was that we emphasized rates, not just dependencies. So a traditional dependency, and not all of them are like this, but traditionally dependency mapping has been very good at finding out that these two servers talk to each other. They have either a socket open or there's an ODBC connection or something like that. And I've tied these two together and I can say they depend on each other. And first of all, that's very important, okay? But the difference between where we were with cloud and data center migration and where we are means that we need something new. Let me explain that a little more. It's not enough to say these two servers are dependent, and so I'm going to put them together and move them. In a perfect world, we could do that every time. But the reality of the situation is with distributed architectures, with for example, in a Windows environment specifically, relying on operating system level functions that may be very chatty, it's not reasonable to think that I can take an enterprise application and put a very neat box around it and say I'm going to move this box. it's likely that that box will always have some, what we might call leakage, right, out of there, that it still needs to communicate to other resources. So the question becomes one of qualitative communication. How much can I support remotely and move into a different data center, into a cloud environment? And that's where you need rate information. So we focused on things like latency, things like throughput, things like packet loss percentages, those qualitative measurements that talk to you about the nature of the communication, not just whether it's there. And now you can make an informed decision. Hey, if I get this much bandwidth, I can support it. And if I can get an SLA with this latency, then I can go. And then if I move it and I have trouble with it, I have a benchmark I can go back to understand what it looked like previously. And so that's really important. And that's a big difference between using dependency visualization from RISC to actually execute something and having a CMDB that has dependency mapping, but is used primarily to tell me if an asset that I'm going to retire in a data center would impact an application that might be used somewhere. Again, that's very important, but the two are distinctly different from an outcome. The application dependency visualization from RISC is really all about giving you the ability to visually explore your data center and your environment at a workload and an application level. And so we designed it because the amount of data that you have to deal with, it's not uncommon for us to collect hundreds of millions of rows of data, sometimes a billion rows of data, in order to build the visualization for a particular data center. Well, that's too much data to consume in any other way except to be able to visually go through it and explore it. So the interface is built to allow you to do that, first of all. Then it's built to help you filter and analyze the data that's there. So sorting different types of communications by either protocols or the amounts or the durations and how often they talk. You can begin to get a feel, right, for what's happening within your environment through that visualization. Then you can begin to put those individual workloads and application stacks into groups and then view things at a group level, which is really important. And then I'd say that the last thing that we think is really neat about ours is the ability to see locations. So having your dependency mapping within your data center is important. Having an idea of the network impact of moving something that communicates with branch offices or internet hosts and knowing what that will do in your new location, whatever that new environment might be, a private cloud, public cloud, or just another data center. And being able to marry that back to the actual users and the locations that those users sit is really powerful. And so it's a great planning tool and an execution tool as you're getting ready to make any of those changes. So the C-level side is almost easier than the IT director side or the person who's using it in a tactical way. Because I think that the one thing that C-level and C-suite people need is information, right? Making a decision based on what's actually happening. Once they have the information, the decisions are what they're really good at. Right now, in too many cases, what they're saying is, I need this information, and they can't get it. We had a customer call yesterday, actually, where I talked to the customer, and what they were looking for is moving a data center, and they're just trying to decide how much bandwidth to get to the other data center. And it is a huge conversation within their, between the CIO and the IT directors about whether they get dark fiber, whether they buy, MPLS, managed connectivity and stuff. Now, these decisions may seem simple, but the reality is the cost of those choices is significant. So a 5-year term on a contract for something like that can run a lot of money. And what they all looked around and said is, we just don't have a way to determine whether we could support this. So if I go to AT&T or Sprint or Verizon or any of these other carriers, do they even have an option for me? And is this even something I can do? So they're engaged with us to use our our dependency application dependency visualization suite to do that, so that they can just determine what that provisioning needs to be. And they were thrilled to just see that that data would be available to them, because they've never been able to get it in that format.